All right, so there we go. Let's go inside. And here is the name of the module, SVM of course, and the class that we must now import in order to build our SVM model. All right, so let's start with this as usual. Let's get, this path and let's adapt it inside our code cell. You know how to do this. We need to start with from. So from the scikit-learn library and then the SVM module of the scikit-learn library, we will import the SVC class. Okay, so that's the first step. And then the next natural step, you know it by heart, it is of course to create an object of this class. And we need to keep here the name classifier, because in order to not have anything to change afterwards, so classifier, which will be nothing else than the SVM model itself. And so to create such an object, we need to call this class, well, I can just type it, SVC, and then add some parentheses. And now the question is, what do we need to input here as parameters? Well, I hope you have the reflex to think, of course, we need to input the kernel, because as I've just explained, this SVC class allows to build kernel SVM models with either a linear kernel, which is the classic SVM model, or a nonlinear kernel. So here in our parameters, we'll have to specify that we want a linear kernel, because we're starting with the classic SVM model. And then in the next section, on kernel SVM, we'll choose a nonlinear kernel like RBF or polynomial, we'll see. But there you go, that's our first argument. And indeed, when we have a look at the documentation, we can see that indeed the second parameter here is kernel. And the default value is RBF, so we'll have to specify that we want linear to start with. And then, as you can see, you have many other arguments, parameters, and you can check out the description for each of them. But no worries, we won't change their default value. We'll just keep their default value, like for example the regularization parameter, for which we'll keep the default value of 1. That's fine. You'll see in the visualization that there is not much we can do in order to improve the model or to avoid overfitting. So there we go. The only parameter that we'll take is this one, kernel equals not RBF but linear. All right, so let's do this. Kernel equals, in quotes, linear. All right, and then I know I've just said that we won't have to input any other parameters, but let's add anyway, this one, the random state parameter, and set it equal to 0, just to make sure that we get the same results displayed on our notebook, because there are some random factors when we build this SVM model, and therefore for teaching purposes, it's better if we all have the same results displayed in our notebook. All right, and that's it. Congratulations, that builds the SVM model, the classic one with a linear kernel, and now you know how to finish this. Of course, our last step here is to take our classifier, from which we're going to call the fit method, to train our SVM classifier on the training set. And we have to input that here in two parts. First, the matrix of features of the training set, which is x train, and then the dependent variable vector of the training set, which is y train. All right, so you know this perfectly well now. It's like your native language, right? Okay, I hope I'm right, but there you go. Congratulations, this implementation is now over thanks to this very efficient code template. And so now, well, we'll just run everything and observe the final results in the end. All right, so let's do this. Let's not forget to, import the dataset here, upload it in the notebook. So click this folder here. Then you will have to wait a few seconds because your notebook will be connecting to a runtime to enable file browsing. And in a second, we should see, there we go, the upload button. So we're going to click that. And well, that's the dataset, but I'll show you the whole path again. So you find your machine learning A to Z folder, codes and datasets, which you could download in the previous tutorial in the article. Then you're going to go to part 3, classification, then to section 16, support vector machine, then Python, and social network ads.csv. You click open, and this will upload the dataset inside the notebook. There we go. And now you can run all the cells by clicking runtime here, and then, are you ready? Run all. And this will run all the cells. And perfect, now we have our SVM model with a linear kernel with all the default values of the parameters here except this one, linear kernel. And so there we go, then we have the rest of the cells. When we predict the new result, indeed we get the right prediction. Remember, it's 0 for that particular first customer of the test set of age 30 and estimated salary $87,000. Indeed, it is predicted not to buy the SUV as it is the case in reality. Okay, then when we predict the test set results, once again we see that we have many correct predictions except some of them. This one, and this one. Okay, but it looks very good. However, what we're mostly interested in, and we're about to get it right now, is to see the accuracy on the test set. You know, the number of correct predictions, or if you want, the number of incorrect predictions. Are you ready? We're about to get it right now, right? That code cell prints the confusion matrix and display the accuracy. And wow, okay, interesting. So it beat actually the logistic regression model, right? Remember, the logistic regression model had an accuracy of 89%. And here, the SVM slightly beats it by 1%. However, it does not beat the KNN model, which, remember, had an accuracy of 93%.